So we want to look at another very important protocol called the ARP, the Address Resolution Protocol. So in order for data transmission to a network destination to be achieved, it is necessary to build an association. Build an association between the network layer and the lower layer protocols. So the means by which ARP, Address Resolution Protocol, is used to build this association and prevent the unnecessary generation of additional broadcast traffic in the network should be clearly understood. By the end of this chapter, it's a very short chapter, you should be able to, number one, Wes. Kama Wes hayuko tayari, George, go ahead, Wes.
So upon completion of this section, we'll be able to explain how the MAC address is resolved using ARP, and explain the function of the ARP cache table.
Cache table, thank you very much. Okay, so yesterday we mentioned of a physical address, physical address, and we said that this is the MAC address, and we went further and said that the MAC address is handled at layer 2, which is called the data link layer. Then we have the logical address. We say the logical address is actually what we call the IP address, and it is handled at layer 3 and is also known as the network layer, layer 3 network layer. Now, in theory, you can just send data with just the physical address, in theory. But in practice, you need both of them. Any computer in the network must have both of them in order to be able to forward data. Now, the reason as to why you need the logical address in order to be able to forward data is because how will host A, in order for host A to send to host B over the physical medium, it needs the MAC address of host B. So how will host A know about the MAC address of host B? So it actually uses the logical address to learn the physical address of host B. And whatever facilitates that particular learning of the MAC address of another device is this protocol we call Address Resolution Protocol. Address Resolution Protocol. So you can think of the physical address as a particular person. Or how can I put it? I'm trying to get an example. No, that's not a good example. Let me just leave it. Okay, so I hope you understood that. So the data link forwarding relies on the knowledge of the MAC address of the data link layer destination. So lazima tujue MAC address ya destination before to forward. So it is this guy, ARP, that is going to help us to discover and learn the MAC address of host B. So in this chapter, that is what we're going to look at, how it's done. So let's begin by looking at the ARP header. So the ARP is actually a layer 3 protocol. It is a layer 3 protocol, and therefore it's a packet. It's an ARP packet. Now, it will be encapsulated. It will normally be encapsulated within the data link layer. So it will have the data link layer header and the data link layer trailer, the frame check sequence, and the Ethernet 2 header. So let's look at the fields. So the first field here is the hardware type. The hardware type is simply the MAC address. Protocol type is used to specify the IP address. Then the hardware length is the length of the MAC address, which is 48 bits. Protocol length is the length of the IP address, which is 32 bits. Then this one is important, the operation code. Now, the operation code can be one of two values. It can be a request or a reply. So it's going to have either, this field is going to have one of these values, request or reply. Then you have the source MAC address. So this is the MAC address of host A. For example, if we are talking in regard to host A and host B. So, and host A wants to learn the MAC address of host B. So source hardware address is the MAC address of host A. Source protocol address is the IP address of host A. Destination hardware address, this is what we want to find out. So we don't have it. This is what we don't have. We don't have the hardware address, the MAC address of host B. Destination protocol address is the IP address of host B. We have it. We have it. So really, what we don't have and what we really want to find is this. And therefore, at this particular point, this will usually be filled with zeros. I think 48 zeros, this particular field. So those are the fields of the ARP packet that are going to help us to learn the MAC address. So how does the ARP process happen? So if host A needs to communicate to host C, it must identify whether it is able to reach the destination at the data link layer. That is, whether it is aware of the MAC address of host C. So it cannot begin to encapsulate the data until it's sure that, hey, I have the MAC address of host C. So in case it does not have it, or now this is the first step. This is the first step, okay. So the first step in trying to find out whether I know the MAC address of host C is what you call the ARP cache lookup. The ARP cache lookup. So every host in a network has what we call an ARP cache, pronounced as cache table. This ARP cache table is simply used to build an association between the logical and the physical address. That is between the MAC address and the IP address, the ARP cache table. So every host has it. So what happens? I want to send to host C. I'll have to check my ARP cache table. The command in command prompt to reveal the values of an ARP cache table is ARP then space, then hyphen, then A. So these are the fields for, these are the columns for an ARP cache table. So the first one is the internet address, then the second column is the physical address, which is the MAC address, then the type. How did we learn? How did we learn this MAC address? We can learn the MAC address in what you call dynamically. So when we are using ARP, but you can also configure it manually. So in this table, we can configure that, hey, hii ndio, we can do it manually like this. The IP address, the IP address of host C is 10.0.0.3. The MAC address of host C is 00-01-02-03-04 CC. So we can configure it manually, or it can learn it dynamically using the protocol. So the first step of the protocol is ARP cache lookup. Okay. Then in the next step, ikipata haina, it will now create an ARP packet. Now, in this ARP packet, it will still have the Ethernet 2 header, which will have the destination and the source MAC address. So the source MAC address is going to be the source, the MAC address of host A. Then the destination MAC address is going to be, you remember this, all Fs, it's going to be a broadcast MAC address. A broadcast MAC address. So everyone in this network is going to receive this frame. Everyone is going to receive it and process it. Everyone in the network. So host B will receive it, host C will receive it. Now, in the ARP header, it's going to define the destination address. So as you can see here, that destination address is actually the IP address of host C. So this guy, when he looks at the ARP header and sees that the destination address does not match its own, it's simply going to discard that frame. It's going to discard it. On the other hand, host C will check the destination IP, see it matches its own, and therefore it's going to process it further. As I said earlier, on the destination MAC address, this is what we are looking for, and therefore we will fill it with all zeros when we are sending the request. In the ARP header, under the operation code field, the value that it will have there is a request. We are sending a request. It's a request. So the operation code field can be a request or a reply. So that is what we call an ARP request. So after sending the request, host C will receive it, process it, and create another ARP packet. But now, before discarding the packet it received, it's gonna update its own ARP cache table with the IP address of host A and the MAC address of host A. And as you can see, under the type, it has learned it dynamically using the ARP protocol. So dynamic is automatically, not manual. So that's the first thing it will do, update its ARP cache table, then create a reply. And this time, because we have the IP address and the MAC address of host A, we are going to send a unicast message to host A. So please remember, the request was a broadcast. Everyone was receiving it. But an ARP reply is a unicast message. So that's a very common question in the exam. Okay, so this is how the request message is going to look like. So destination MAC address is going to be the destination MAC address, the MAC address of host A. Source is coming from C. then the ARP header will look like this. So the most important thing to remember here is that the source MAC address will be the MAC address of host C, and therefore this guy is going now to know, oh, this is the MAC address of this guy, and therefore he's going to update his own ARP cache table. In the operation code field, this time it's going to be a reply. Okay. So now if we do in host A, if we do ARP -A, we should see that it has already updated the details of host C in its ARP cache table. Now, something important to note is that this entry that is made in the ARP cache table is actually temporary. It's actually temporary. So it stays there for a few seconds. So it's not permanent. I think I don't know the default, but please go and read. I think it's about, I'm just guessing, about 30 seconds there. Reason being, the IP address of host C can change anytime. For example, if you restart host C, maybe it's going to request for a different IP address from DHCP, from the server that is issuing IP addresses. So that's why entries in the ARP cache table are not put there forever, just for a few seconds. So as long as we have this entry here, we don't have to do another ARP request. So if this time host A wants to send a packet to host C, it's gonna check its ARP cache table, see that, hey, if you want to reach this guy, hii ndio physical address yake, itaunda hiyo frame na itume direct, so haitafanya nini tena. But after 30 seconds, hii entry ikiwa deleted, aangalie apate ai hakuna, then itabidi amefanya request tena. Na problem na request ni nini? Request ni broadcast, itaenda kwa huyu pia itaenda kwa huyu. Shida ya broadcast ni nini? Sometimes zikiwa mingi kwa network ina cause congestion. They cause congestion and delays. Congestions will lead to delays in your network. Okay, and then we have the concept of proxy ARP. Proxy ARP. So proxy ARP is what can I say? Most of the time, you'll use a layer 3 device to break your network into different segments. Reason being, you want to reduce what we call the broadcast domain. You don't want one network segment to have so many devices, because when you have so many devices within a network segment, then the number of broadcasts are going to be so many. Because tumeona, anytime a machine wants to send to another machine within the network, they have to generate an ARP request, which is a broadcast. So how does the proxy ARP really work? So in this particular example, we want to send a packet to host B. So first thing we do, we check our ARP cache table. We don't find any association between that destination address in our ARP cache table. So what do? We generate an ARP request. That ARP request is a broadcast, and this guy is going to receive it. Our gateway is going to receive it. Then the gateway will look at that address in the ARP header. In the ARP header, we have the protocol, the destination protocol address. So it's going to see that, hey, this address is for someone that is in in my other network segment. And therefore, what the router is going to do, it's going to save in its ARP cache table. It's going to save the MAC address and the IP address of host A. Then it's going to create a new ARP request and flood that request to this network segment. So everyone in this network segment is going to receive that ARP request. So whoever has this IP address is going to reply. Now that is host B. They're going to reply with their MAC address to who? To this router here, to the gateway. Now the gateway again will update its ARP cache table with the MAC address and the IP address of host B. Then now this guy is going to send a reply to host A. But he's not going to send the MAC address of host B. He's going to send the MAC address of this interface. So as you can see here, we are sending the MAC address of G000. So now this guy will update its ARP table that if I need to reach host B, I'll need to use the destination MAC address of this guy. So this guy will be acting as a proxy. Because you have to send to this guy, then this guy will create a new frame with the destination MAC address of host B, then forward it to host B. So that is what we call a proxy ARP. So ni kama broker. So wewe unataka MAC address ya huyu, lakini mimi nitakupea yangu because ndio uende kwa huyo lazima unipitie. Then ukinipea mimi nitatumia huyo. Another thing that is important to note here is that a gateway or a router does not forward broadcast traffic beyond the network from which it has been generated. So what will happen is that when it receives this broadcast ARP request, it's going to create its own ARP request, then send it as a broadcast to that particular network segment. That one. Okay. So the other concept that is interesting about ARP is what we call gratuitous ARP. Gratuitous ARP, some people call it gracious, some people call it gratuitous, I don't know. So gratuitous ARP is used for one main purpose, to ensure that every IP address in the network is unique. Therefore, ensure that we do not have duplicate IP addresses being assigned to any network device. So, in order to ensure that every address is unique, we normally use ARP to do that. So how does it work? Anytime you add a device to a network, you'll either configure manually an IP address to that device, or it will be issued using a server we call the DHCP server. There's a whole topic about DHCP we're going to learn. So once it receives that device, it's gonna generate an ARP request message. ARP request message. Remember, ARP request is broadcast. Now, in the ARP header, it's gonna put the destination IP address as the IP address that you've assigned it. So look at that address and this address, they're the same. In the source IP address, it's gonna enter all zeros. So in case it receives a reply, from anyone for this particular ARP request, then host A will know, hey, someone else is already using this particular IP address. And that is how operating systems are able to tell you. Sijui kama ushaijaribu. If you've ever tried to configure an IP address manually within a network, and someone else is already using that IP address, the operating system will tell you that you cannot use this IP address. It's being used by someone else. How did it know? Through Gratuitous ARP. Through Gratuitous ARP. So I hope you've understood how Gratuitous ARP works. Anyone with a question? You've been silent for a while now. Kimeeleweka? Mabibi na mabwana?
Yes, we can continue.
Yeah, iko sawa.
Okay, asanteni sana. Okay, so that is it. So prior to generating an ARP request, what action must be taken by an end station before generating an ARP request? So this one I'm going to call out on someone to answer it. Michael Kimita. Michael, are you there? Just unmute your mic and answer the first question.
Hi everyone, I'm here.
Hi, yes, go ahead.
Kindly let someone else answer that because I wasn't around for a bit.
What about the next one? You can answer the next one.
Mm-hmm.
Okay, Gadudi, you can help us with the first one. George, prepare to answer the next one. Yes, Gadudi?
I can answer the second one.
Go ahead.
I can read the question. When a gratuitous ARP message generated and propagated on the local network,
Yes.
they are generated when the IP address is duplicated.
When an IP address is configured on a device, when a new IP address is assigned to a device. Okay. Yeah. Okay. Thank you. George, you can answer the first one. G. Okay, so I'll just answer the first one because now it has had so many misses. So prior to generating an ARP request, the end station must check its cache table. It must check its cache table and ensure that there is no entry. So if there is no entry, then you go ahead and generate an ARP request. If there is an entry, go ahead, make up the frame or packet and send it to the destination. Okay, thank you very much. So that is it.